right.
Oh, this is the bread page. Oh.
Yeah. So section 7.2 is on volume. There's two different methods we're going to learn. The disc or washer method, they're the same thing. And we're going to learn the shell method as well. The shell method's not on the AP test as of right now, but sometimes it does make things a lot easier, so I figured the more ammo you have in your pocket, better. All right, so it says we know for that shapes with two congruent bases called cylinders or prisms, the volume equation is V equals the area of the base times the height. Do you guys remember that from geometry? It's been a long time. But.
Yes.
All right, so if I can find the area of the base and then multiply by the height, that finds the volume. So what's the area of these bases? So what kind of base do I have? Circle. Those are my two congruent bases. So it's pi r squared. So it's 6 inches. So pi times 6 squared times my height was 20. So it's pi times 36 times 20. So 36 times 2 would be 72, so add another 0, so 720 pi. What are my units?
Inches.
Inches cubed, right. So volume.
That's it?
Yep.
Where's the integrated?
Haven't done it yet. Okay, so now my bases are, so the two things that are parallel, pentagons. Oh, it looks like my little thing got moved over. Was yours moved over? Or yours is good? I need to fix that in my notes. So that was supposed to be, it's supposed to be like over here. You see it? It got moved over. Yeah, so you guys have a little triangle that has 54 degrees. Do I have any other measurements on there? No. 8 feet is the side. Think about it. So I have 10 of these. You see 10 of the little triangles. See how it works?
Oh, okay. Oh.
All right, so if it's 8 feet on the side, that means this bottom part's 4. It'd break into 4 and 4. So in order to find the area of this triangle, I need the height of the triangle. So how do you find the height of the triangle? No, that's the area of the triangle. How do you find the height? Yeah, so this is, let's be x. So we have opposite over adjacent. So Katie's saying tangent. So it's tangent of 54 degrees equals opposite over adjacent. So x over 4. So it's whatever 4 times tangent of 54 degrees is. Okay, so make sure your mode is degrees when you're doing this one. Yep. So 5.506. You rounded, so if you want to store that as something, just in case you have to use it, let's store it as A. So stow, A. So it's in there. All right, so I have 10 of those little triangles. So those little triangles have the area 1/2 base times height. So base was 4, height was that A value. I'll just write A. So I got 11.011. Okay, I'm going to store that as B, just in case I have to use that. All right, so my area of my base is 10 of those things. Does that make sense? Do you see 10 of them? So I have 10 times 11.011, which we stored as B, times H. So the height of my prism is not the height that I found before, it's this. The height is always the distance between the two bases. So the height is 12, so 12 feet. So I take my number that I have stored times 10 times 12, or times 120. So I get 1321.327. Okay, so the way we did that ensured that we didn't have any rounding error. Like we just kept storing the answer, storing the answer. Our units are cubic feet. Can we go back? Okay. Yeah, I have this nice drawing of bread. So it says sometimes we don't have cylinders or prisms. So sometimes we don't have those things that have two parallel bases, so we can't use those formulas. Instead, we're going to have to use calculus. So it says we can find the volume with a method similar to finding the Riemann sum. Do you guys remember when we first learned the area, we added up all the rectangles? Same kind of thing. It says we cut our shape into S pieces called cross sections, like a loaf of bread. So imagine we're chopping. I always want to bring in Play-Doh and do this, but
Do you think we need it?
it's a little rough. I've tried thinking about, because a lot of these are like rotated around. Like think of the wheel, like you know how I helped out with wood fire ceramics, and the wheel goes around and it creates the same shape like all the way around. So if you want to like bring your fingers in, it makes it like tapered. That's kind of what's going to happen on these shapes. We're like flipping them around the x-axis, so it's like symmetric all the way around. Okay. So it says the same is true for a sphere. Sketch several vertical cross sections of the sphere below. So we're going to go like this. So it's like I chopped it straight down the center. So do I need to draw the back, or you guys get the little dotted lines? Okay, so we call these discs. Like a CD is a disc, right? Makes sense why it's a disc. Now if you do an infinite number of these, you know, right now this disc is looking like, this is going to be a terrible, like you know, it has some kind of width to it. But if I keep chopping and chopping and chopping, there's no width to it. So in that case, it's just like the area of a circle. Do you see what I'm saying? So we're adding up an infinite number of areas, which is strange, but that's what we did for rectangles, for our area. Okay, so it says definition of volume. Let S be a solid that lies between A and B for x values. If the cross-sectional area is A of x for each x value. So, I mean, these circles could have different areas. It just depends on where we're located. Then the volume is V equals the integral from A to B of AX dx. Okay. Okay, so find the volume of the solid obtained by rotating about the x-axis, the region under the curve, y equals the square root of x from 0 to 1. So square root of x looks like that. 0 to 1. Okay, here's my x-axis. So I'm going to go around and around this x-axis. So like I was saying, think of like a potter's wheel. So it's just spinning around and around and around that x-axis. Think about what kind of shape it's creating.
Circle. Circle.
It's a what? It's not really a circle.
Sphere.
Bullet.
Yeah, it kind of looks like a flat bob.
A disc.
Yeah, it's like, this is going to go
pot that
around.
won't stand up.
Yeah, it's kind of like a bowl.
Big old ugly bowl.
Yeah, did you guys see it?
Yeah.
So it's coming around and around and
Yeah,
around.
it's like a toilet.
This is inside.
Thanks for pointing
So it looks like that.
Yeah.
All right.
that.
Yeah. Do you see it?
Yes.
Now, what this was the area under the curve. So it was actually this whole area. So what's happening is this whole thing's solid. So there's no like hollow piece in the middle. So I drew it kind of like it was hollow in the middle, but it's not. So you have this, it's going around and around and around. And it's just a solid, it's like a bowl that's filled in. Okay. So we need to think about the area of each cross section. So when I slice this, what does the cross section look like?
Looks like kind of a bowl.
A disc.
A disc or a circle, right? It looks like a circle. So the slices are circles. So the area of a circle is pi r squared. Well, what's the radius? So if I go straight up, so what's the radius? It's whatever, like, it was the y value, right? The square root of x. Yeah, it changes. So when I was down here on the axis, my radius was 0. When I moved over a little bit, it got bigger. And then at the end, the radius was 1, right? So my radius is getting bigger. So my radius is square root of x. So it was your y value. So that means when I'm finding the volume, I'm going from 0 to 1 for my x's. I have pi, my radius squared, so square root of x squared dx. So I'm adding up all of those circular sections. Okay, so that's just, you can pull the pi out to the front. So it's just x dx, which is pi x squared over 2, going from 0 to 1. Oh, it was squared. Yep, pi r squared. So what do we get? 1/2 pi or pi over 2. Good. So that's the area.
Where's the limits of integration come from?
It's the x value you go from. So it starts at 0 and it goes all the way to 1.
How do you know that? Oh, 0 to 1.
Yeah, from 0 to 1.
That's good. Good for,
All right.
good for that.
Let's see where my timer's at. Should I stop it, you think? We'll stop. The next one might take longer than maybe. It keeps going.
You want to press
Go, stop.
Press stop.
I am. I'm pushing it. No, the other
Let's
stop.
record.
Square.
This is stop.
Oh.